next we have a recap about potential energy U and force F. So this is just a fundamental relationship in physics. We know force is equals mass times acceleration, so kilograms over meters times seconds squared. And potential energy is measured in joules, which is kilograms, this should be in the top here, meters squared over seconds squared, meaning that to get to the potential energy, we have to add a meter, add a distance, so giving us the relationship of, this is actually kinetic energy. Sorry, U is the opposite of kinetic energy, but Ke equals the integral of F with respect to X, because we're adding in a distance. But essentially force, we know that adding in a meter, Newton meter is joule, is the unit of energy. And we're talking about kinetic energy here when we're doing force over a distance. So we also know that by conservation of energy, the change in kinetic energy is the same thing as the change in potential energy. It's just negative. These two are kind of opposites. So therefore, substituting in U equals negative Ke, we get U equals the negative integral of F dx. Pretty fundamental relationship right here. The negative comes with just kinetic energy being the opposite of potential energy. So yeah, we'll be able to do 29 pretty easily. It's just about the integral and areas under the graph. So yeah, cool. All right, problem 29, we have a graph of force versus X displacement, and it goes like that. And here is 0.1 meters, and this is just force in newtons. And it asks us about the change in potential energy of the system as it moves along from 0 to 0.1 meters. And again, the key thing to remember is that change in potential energy, delta U, equals negative integral of F force dx. This is because change in kinetic energy is the positive integral. It's defined as force times x. So therefore, potential energy is basically the opposite of change in kinetic energy, and we get delta U equals negative integral of delta U equals negative integral of F dx. So meaning, as you move along here, the change in potential energy is going to be the negative area under this curve. And so since this curve is already negative, it's already under the x-axis, as you sweep along, it's going to be positive, and it's going to be more and more and more and more positive because we're getting more and more and more negative area as we keep sweeping. The rate of increase does start to decrease, but the entire time it is still increasing because the area is always negative, meaning that the potential energy, which is the opposite of the area, is always going to be increasing, and that is answer choice A.